So Ignite is a rural innovation hub, which is a fancy word to basically say that we support rural entrepreneurship. We have 4 main pillars that we work out of. So I do youth programming. We also deal with startups and entrepreneurs. We connect industry with startups and kind of do industry-led initiatives, so fun challenges and stuff like that. And then also connecting entrepreneurs and startups within the community to kind of build like that support network and things like that. So I'm kind of new to the role of youth programming, but we are working on offering new online and whenever it's safe to do so, in-person events and programming. But yeah, it's really cool to be able to have an initiative like this, the Young Women in Ocean Tech, to kind of give the platform for everyone to be able to connect together and kind of see what awesome female, industry experts are all around us, and being able to kind of see what is possible in Nova Scotia, that you don't have to leave and that you can stay here, and the future that's possible for you. It's really cool.
It's very cool, Tristan. Hey, Margaret, why don't you describe what you do with the Idea Hub?
We do all sorts of fun stuff. I'm going to argue that I probably have the coolest job here, but I welcome people to argue with me or try to just disagree and tell me how great your job is. So I am the director of the AMERA Idea Hub at Dalhousie University. I am part of the faculty of engineering at Dal, but I work with teams across all different sectors, all different backgrounds, a really strong focus on STEM, but all different areas. And what I do is I run an incubator, so similar to Ignite, but I'm focused on supporting getting technologies out of the university. So if a student or a researcher at Dal or a faculty member comes up with something incredible, they invent something in their lab, my unit and what we do at the Hub is we support them in getting that out of the lab and hopefully turning it into something that we can get on the market and into the real world. So I'm helping innovators and tech-based teams at the earliest stages, taking something from research to an actual product. And we specialize and really focus at the Hub, at the AMERA Idea Hub, on physical product and on prototyping. So we've got over 40 teams participating in our programs right now. They're all incorporated startup companies just getting going, and they're all building and developing physical technologies. And here in Atlantic Canada, being located in Halifax, a lot of our teams are working in the space of ocean tech. That's a big area. So whether it's underwater sensors, whether it's new paints and coatings for marine vessels that are greener and safer, we're supporting all sorts of teams in those spaces. So I get to see the world-changing technologies that are coming out of our region, which is pretty cool, and work with a lot of engineering students and faculty and staff at Dalhousie and all sorts of research institutions across our region.
That's great. Thanks, Margaret. I think I see Anna is back. Are you back there, Anna? Should we go ahead and get started?
Yeah, I think we can probably get started, and I'll type in the chat as people seem to join on, Tristan. So
okay, awesome.
Go ahead and take it away.
Awesome. So thanks everyone for joining us for the first session of the Young Women in Ocean Tech speaker series. We're really glad to have you here. It's an excellent opportunity for you all to learn more about the ocean tech industry and get hands-on with the design thinking workshops later on. The best part is that it's a fully women-run initiative to show you what talent exists all around us and what jobs are out here for you, like right in your own communities. This project wouldn't be possible without our great funders and partners, so the Center for Ocean Ventures and Entrepreneurship, COVE, the Department of Education and Early Childhood Development, Ignite, Dalhousie University's AMERA Idea Hub, and DeepSense, with additional support from IBM Canada and Engineers Nova Scotia. My name is Tristan Mabey. I'm the Youth Program Coordinator here at Ignite, and I'm joined with Anna Naylor, who's the Manager of Learning Programs at COVE, and we're going to be running the speaker series today. So to kick off the first session, we have Jennie Korus, an aquaculture scientist at Innovasea with a background in marine biology. If you're interested in learning more about her path that led her to the career that she has now, you can always drop a question in the chat and anything that you might want to know. She's going to cover the innovative technology that was developed by Innovasea that's revolutionizing how farmers care for their livestock. She's also going to be providing an overview of the tech and some of the sensor applications that are being used in farms. So without further ado, hand it over to you, Jennie.
Great, thank you so much. I'll just start by sharing my screen so you can see my presentation there. Yeah, I can't actually see the chat window, so if we can either wait and take those at the end, or if you just want to interrupt me and come off mute and ask me a question, please feel free to do so.
I can see it, Jennie, so
okay.
I'll intersect too if we have questions come in.
Perfect, thank you. Great, so first, just thank you so much to Tristan and Ignite for facilitating this event, and to Sherry and Anna at Co for getting me involved. I'm really looking forward to talking a little bit about the aquaculture industry and some of the tech that we work on at Innovasea that's helping farmers grow their fish sustainably. I also just wanted to acknowledge that I'm giving this talk from Mi'kmaq, the ancestral and unceded territory of the Mi'kmaq people. So I'll just start with a little background on myself and just sort of how I ended up here. So I did grow up in Toronto, but I remember when I was in my last year of high school, and all anyone really wanted to talk about was where they were going next year and what they were taking and what job they wanted their degree to lead them into. And I knew that I wanted to study marine biology at Dal, but I never really gave much thought to where I would end up after that. So once I graduated and I wasn't instantly a marine biologist, I wasn't really sure what to do. And so I had to do some reassessing. So I ended up traveling abroad a little bit and working, and ended up with this really amazing internship working with these acoustic tags tracking whale sharks in the Red Sea. And it was kind of there that I realized that it was this technology that enabled us to do that. That was what interested me so much. And so I decided that the ocean tech industry was a space that I wanted to explore a little bit more. So I ended up registering for the Advanced Diploma of Ocean Technology at NSCC. And it was there that I gained some awesome firsthand experience learning about and using all sorts of equipment that's used by oceanographers to study the ocean and everything in it. And as part of this program, there was a mandatory internship. And so I ended up completing mine with Innovasea as an ocean technologist. And that's where I kind of learned all about the aquaculture industry. And then just last year, I transitioned into my current role as an aquaculture scientist. And it's been a part of this role that I've actually enrolled back in school. And I'm now completing my master's in oceanography at Dal, studying fish welfare on aquaculture farms. But you didn't really come here to learn about me, so I'll get talking a little bit more about some of the more interesting stuff. So as you may know, or may not know, our population is currently growing at an exponential rate, and we are at a population of about 7.5 billion people. And we expect this to grow to nearly 10 billion people in just the next 30 years. So it's becoming increasingly critical for us to invest in solutions that enable us to feed our planet sustainably. So starting in the 16th century, fishing vessels would go out to sea and they started to catch fish for human consumption. And we started fishing in waters that were close to shore, but we were limited by our boat size and our ability to keep products fresh. But as technology advanced and we were able to fish longer, catch more, and move further offshore to more abundant populations, and as the demand increased, so did the advances in technology.
Yesterday, GameStop was going out of business.
And so as the demand increased, so did those advances in technology. And so we were becoming increasingly proficient at fishing more out of our oceans. But obviously it comes as no surprise that our planet has limited natural resources. And we're really only beginning to understand the impacts of losing these wild fish stocks that are unable to sustain themselves at the rate that we're currently harvesting them. And so when we take stock of our global marine fisheries, the trends that we can observe are, and you can see them here in this figure, are kind of concerning. The percentage of overfished and fully fished stocks are increasing, and the number of available non-exploited stocks are decreasing. And that's because what's happening is we're fishing a certain stock of fish until it's no longer sustainable, and then we're moving to exploit a new stock. So the question is, what happens when we run out of new stocks to fish and there's nothing left for us to exploit to feed our ever increasing populations? So I'm going to put a quote up here by Jacques Cousteau, who's a famous explorer, scientist, conservationist, general ocean advocate. And he once said that we must start using the sea as farmers instead of hunters. That is what civilization is all about, farming replacing hunting. And so this was quickly realized on land with the development of intensive agriculture, which has obviously been around for hundreds of years. And this is hundreds of years to kind of practice and perfect it into this fine science. But when we compare this to intensive aquaculture, and specifically with salmon and other finfish, which really only started in the last 50 years, it's pretty clear that this industry is still in its infancy. And even without hundreds of years of practice and development, salmonids and other finfish species maintain some of the lowest feed conversion ratios of any livestock. And this is basically an efficiency measure of how many resources are put in versus how much we can harvest for consumption. And so just as we have put development and effort into developing sustainable agricultural practices, we kind of have this unique opportunity right now, while this industry is still in its infancy, to develop sustainable practices for aquaculture. And in turn, this will hopefully help us release some of the pressure that we have placed on our oceans. So obviously the habitat in which these fish live in is very different than the one that the agricultural livestock experience. Their experience is one that is extremely familiar to us because it's the one that we experience every day. And a coworker of mine actually once said it quite eloquently. He said, you know, if we're hot, the cows probably are too. But it is really that intrinsic knowledge that has made it so much easier for us to care for farm animals and kind of presents us with the challenge that we're faced with today. And that is that when we're farming fish in an environment that is largely foreign to us, how do we ensure the welfare of those fish while still maximizing production rates to meet the increasing demands of sustainable protein sources? And so the answer to that question, I think, lies in data and technology. So up until quite recently, the data collection methods for salmon farming were very primitive. In order to determine the welfare of the animals and acceptable feeding windows, workers would need to measure dissolved oxygen levels on the farm. And dissolved oxygen is really this kind of key parameter to ensure fish welfare and survival, because like us, they need it to breathe. But ocean is not really as readily available as it is in air, and it's constantly changing. So what site workers used to do is they would take a single handheld measurement to take measurements from a single location, maybe once or twice per day on the farm. And this led to very reactive farming practices, and it offered no insight into what conditions the fish were experiencing between these measurements. But if we look at the variability of dissolved oxygen across a single farm in one day and within individual pens, we know that these conditions can change drastically. So in order to provide the best care for these fish, it's really critical to monitor all of these pens continuously and independently. You know, each cage is really experiencing its own kind of microclimate, depending on the biomass, the surrounding currents, speed, and directions, and what oxygen levels they are in the pens. And so we have to treat each cage individually so that we can provide maximum care to those fish and minimize any potential food waste. So with our environmental monitoring system, it's now possible to outfit an entire farm with these dissolved oxygen sensors that will collect your data 24/7 and give access to, give those users access to their data in real time. And so this capability has really kind of revolutionized the way that these farms are operating and enables the farmers to make educated, data-driven decisions for all of their day-to-day operations. So this technology is kind of the core of what we in the Aquaculture Intelligence Group at Innovasea provide. You might recall the acoustic fish tags that I mentioned earlier that we use to track the whale sharks in the Red Sea. Well, funnily enough, it's those tags are produced also by Innovasea, by our fish tracking group. So we both use the same technology concept in our equipment. And Innovasea is really kind of known for developing this crucial underwater acoustic communication method that is really applicable in a wide range of industries, but I'm just going to focus today on how we use it in the aquaculture industry. So what it is that we're actually using sound as a method for transmitting data wirelessly underwater. So we've developed a suite of environmental sensors that send out these pings of underwater sound, and these pings are picked up by this underwater listening device, which is called a receiver, and it's tuned specifically to hear these sensors. And so this receiver is typically in a central location on the farm, and it's cabled to this surface unit called the hub, which is able to connect to the cloud through a Wi-Fi or a cellular connection. And this is what allows users to access their data in real time through our software platform using either their laptop, a phone, or an iPad, whatever they have, all in real time. And so not only does this kind of technology allow users to access their data anytime, anywhere in the world, but it enables them the capability to start observing trends over time and understand what conditions might be the precursor to these low or high dissolved oxygen events. And obviously, as this tech kind of advances and we start to implement things like machine learning and advanced algorithms, this could lead to the development of software that would actually be able to predict future conditions. And so farming would no longer be reactive, but proactive. And if farmers can predict these low oxygen conditions, then they can start to take preventative action to improve the water quality accordingly. So for example, feeding windows are something that rely on dissolved oxygen levels because the levels have to be high enough for farmers to feed because fish use up oxygen during the metabolic process. So typically farmers will choose not to feed when the oxygen is low. But if farmers can maximize these feeding windows through these kinds of predictive analytics, then they can complete their grow-out cycles in the shortest amount of time. And this can have really powerful cost benefits. A shorter grow-out cycle means that less feed is used, and less feed is the single greatest cost variable. So that can have really significant impacts on production costs. A shorter grow-out cycle will also limit the window for exposure to parasites like sea lice, and it'll also reduce the fallowing period between production cycles, which is basically the period of time that a site has to be empty from one harvest cycle to the other. And the shorter the harvest cycle, the shorter the fallowing period. So dissolved oxygen is probably the most important parameter to measure for fish welfare and for feeding, but there are many others that we have to kind of consider when we're trying to characterize the living environment of these fish. And all of these parameters interact with each other, they affect dissolved oxygen levels, and they help us to understand why certain cages exhibit better dissolved oxygen levels than others. And so by collecting multiple data variables continuously, then we can provide more information to these kinds of models that will predict environmental changes and give more information to the farmers to enable them to make better decisions. So our sensors collect all sorts of data, such as current speed and direction through the water column. We have sensors for wind speed and direction, salinity, temperature, chlorophyll, blue-green algae, turbidity, and they're all collected and accessible in real time. So I'll just go through a couple of these sensors and briefly explain what they measure and how they work. So I've already talked a little bit about dissolved oxygen, but some other key parameters are temperature and salinity. So all of our sensors measure temperature because it's really such a key variable and it's also quite a simple one to measure. But our salinity sensor actually measures the conductivity of the surrounding water. So it's measuring the ability of the water to conduct an electrical current. So the more dissolved ions like sodium and chloride or salts in the water, the higher the conductivity and the higher the salinity. And salinity is a much less dynamic measurement compared to dissolved oxygen, but it's still important to measure. Most species of fish can tolerate some salinity fluctuations, but it's important to maintain that whatever that tolerance is, the level is kind of maintained. So our current sensor is another kind of interesting one, which also makes use of underwater sound and something called the Doppler effect, which if you've taken grade 11 or 12 physics, you might be familiar with. But basically it states that that a sound wave has a higher frequency and pitch when it's moving towards you compared to when it moves away. And so the current profiler will transmit these pings of sound at a constant frequency. And so those sounds will then reflect off of particles in the water and travel back to the sensor. And because the current profiler knows the frequency at which it's sending out waves, it will measure the frequency of the returning waves and then use principles of the Doppler shift to calculate how fast those particles and the surrounding water are moving. And so these sensors are really helpful to understand some of the hydrodynamics around a farm, which gives great insight into why these different cages are experiencing different microclimates. The prevailing currents actually determine which cages will receive the most flushing. And this is basically the mechanism of bringing in fresh, new oxygenated water. And the strength of those currents will determine how that water moves through the cages. So another sensor is our turbidity sensor, which generally gives the user an idea of the clarity of the water. So the turbidity sensor is an optical sensor, and it emits an infrared light into the water column and determines the particle density based on how much light is reflected back. So any natural body of water will contain some amount of suspended material, whether it's algae or runoff or sediments, and the size and the concentration of these particles will determine the turbidity of the water. And so this is important to monitor typically from the perspective of fish gill health. There are concerns from farmers that if the turbidity is too high, that the suspended materials can clog the gills and irritate the fish. And then in really high concentrations, there are concerns that this can actually affect the fish's ability to take up oxygen. And so the final sensor I just want to highlight and talk a little bit about and some of its interests and applications is our chlorophyll sensor. So the chlorophyll sensor is another kind of optical sensor that uses light to measure concentration, but it's looking for a more specific material compared to the turbidity sensor. So you probably know of chlorophyll as the pigment in plants that give them their green color and allow them to photosynthesize and in the ocean. Chlorophyll is found in all algae or phytoplankton, which serves the exact same purpose as land plants. You know, they take up the sun's energy and take up carbon dioxide, produce oxygen, and they're the base of our ocean's food web. So why are aquaculture farmers interested in chlorophyll sensors? Well, this sensor can be used to estimate the concentrations of phytoplankton in the water. And while these organisms are crucial for sustaining marine life, in certain situations, these organisms, their populations can grow exponentially or bloom, and the consequences of this can be quite harmful. So these blooms will typically occur in the spring and the fall when the conditions are just right. There are higher light levels for more photosynthesis. There's upwelling, which will bring these nutrients up to the surface for the phytoplankton to feed on, and there are warmer temperatures, which enable faster growth rates. The problem is that when these species grow to these really high concentrations really quickly, they can actually end up depleting the oxygen in an area, and this can cause harm to the nearby fish that need that oxygen. And there are some species of plankton that can even cause issues in really small concentrations because they produce these neurotoxins that can harm or kill the fish directly. So because of this, farmers will invest a lot of time and a lot of effort into monitoring chlorophyll levels and sampling for what kind of species are in the area at all times. So hopefully this gives you a little bit of an idea of how some innovative technology is helping to shape this industry that I really think has a lot of potential to really make a difference in the future of sustainable food production. And I just wanted to finish with a couple of lessons that I've learned along the way, and hopefully for any of you who are interested in the aquaculture industry, or even more generally the ocean tech industry as a whole, hopefully this will help you to pursue whatever your passion may be. So the first one is networking. I think this is a really underrated skill, but it's something that you can and should practice whenever possible. And you're here listening to this, so you're already taking steps in the right direction. But honestly, I never would have ended up with the internship working with whale sharks without a connection that I made through joining a society of marine biology students in university. So join student clubs, introduce yourself to your teachers, your professors, volunteer, anything that can help expand your network of people who have similar interests to you. So another thing that I learned is that there's really not one single path that you have to take in order to achieve your goals. I think there's this kind of common misconception that in order to be successful, you have to check all the right boxes in the right chronological order. You have to go to university and you have to do this, you have to do that. But there are so many college programs, work experience, internships, so many different routes to the same job. And it's important to think about what your strengths are and understand where you're going to succeed the most and use your strengths to achieve that goal. The last thing is just don't give up. If you're passionate and you're willing to work hard, everything will eventually go according to plan. I remember when I first went to Dow, I went there because of the great co-op program that it had. And in my first year, I didn't even end up getting into the program. And I was so devastated and I really couldn't see the alternative path to what I wanted to do. But I ended up talking to an advisor in my program and they suggested that I pick up another major to round out my skill set. And so I ended up graduating with a major in statistics. And so because of that, I learned how to program, and that set me apart from other applicants and helped me get my internship with Innovasea. So don't fret when things don't go your way. You just kind of have to pivot and find a new way. So I'm going to end it there, but I'm happy to take any questions you might have, and my email is on this slide. If anyone wants to reach out with any questions relating to anything that I've talked about today, please don't hesitate. Thank you.
That was awesome, Jenny. Thank you everyone for participating. Does anyone have any questions? You can just unmute yourselves or drop it in the chat.
Yes, thanks again, Jenny. I guess I'll just start off the conversation while we wait for other people to maybe add in. But one of the things that I find so interesting about the ocean tech sector is the interdisciplinary kind of side of it all. How did you find that when you were working? I know you mentioned that you had stats too. Do you find that when you're working with a broad range of team members with different backgrounds?
Yeah, I think in any project you kind of work on, you need a little bit of experience from everything. There's a technical background for some pieces, there's engineering requirements, there's the science side, there's marketing, there's sales, like there's so many different kind of jobs that all relate to, like those are kinds of the people that I tend to work with a lot. And so if you're involved in any of those kinds of positions, then you can get involved in the tech industry.
Perfect, thanks. And we have another question, and they're asking, what courses did you take in high school to get where you are today? And if you could, would you have chosen something different?
That's a good question. So in grade 11 and 12, I made sure that I took most of the core science classes. So I ended up taking biology, chemistry, and physics. At the time, I regretted taking physics because it was probably the worst mark that I ever got. But those concepts came in really handy later on. And that's another thing that I kind of learned in high school and in university was that hard courses are worth it, even if you get a bad mark and they negatively affect your GPA, if you learn something from them. A couple of courses that I took, I got the worst marks in them, and I was so upset at the time because that's my GPA, but nobody looks at that. If you understand those concepts, and they will help you in the future.
Perfect, thanks. Are there any, I'm just trying to see if there's any other questions. There's no other questions coming in. We'll give everyone maybe another minute or so. And if you don't want to speak up, again, you can just put it in the chat. Here's another question. Can you share a bit about your job and what you do get to work on at Innovasea? Like, what does your typical day look like?
Yeah, so we're kind of a small group. So that's one of the things that I really like about it is it really kind of changes day to day. So right now, one of my main focuses is working on submitting a proposal for a research project. So right now it's it was writing this proposal, and now there's a lot of back and forth about getting the proposal accepted. And then hopefully once it's all accepted and moves through, it'll be working on that project. And so that's when I talked a little bit about the plankton monitoring, we're trying to develop some hardware and software for farmers to sort of better be able to predict phytoplankton and potentially predict harmful algae blooms. So that's kind of what my main focus is right now. But I also do a lot of science communication. So I kind of work on writing a blog and some white papers that kind of explain to our customers some of the science behind the tech that they're using and why these sensors are so helpful to them and how they work and how that kind of helps them in their day-to-day. But it really does range. I also do a little bit of customer support for some of our clients when they have questions about their system and how it's working, a little bit of data analysis here and there. So it's really widely varying, and some field work when I'm lucky.
Yeah, perfect. And another person asked, what are some things engineers may work on in the ocean tech? Yeah,
so engineering is a huge field in ocean tech. I mean, all of our sensors, our whole system was designed and physically built by mechanical and electrical engineers. So having that background in ocean tech is absolutely invaluable. But even when I was working as a technologist, I got to be involved in some of that. So I didn't design the products, but I could help build them. I could help troubleshoot what was going on with them. And so you don't have to be an engineer to be involved in some of that technical side of it, as long as you kind of get an understanding of how it works and what are some common issues that break down. Even as a technologist, you can kind of diagnose some of that and fix that.
And apart from marketing and statistics and engineering areas, do you think that psychology would be a use in the ocean tech industry too?
That's an interesting one that I've honestly never really thought about, but I'm certain that there would be ways that could be applied. You know, something that comes to mind right now, you know, especially with aquaculture, which sometimes kind of has a little bit of a negative connotation with it. There's this kind of concept of social license and, you know, do the people where aquaculture exists, do the communities accept aquaculture for being there? Are they happy to have the farms there? Are they not happy? And so there is actually a student in my lab, she actually did sort of a survey of all of the kind of partners who are invested in aquaculture to kind of see what they think about it. And so that would be more of a psychology application to the industry, and that's specific to aquaculture, not really so much the ocean tech, but I'm sure that there are similar projects with other ocean tech industries.
I would imagine that it would play a role in machine learning, AI, and that too.
Yeah, that's a great point. Yeah.
Perfect. I love all these questions. These are great questions.
Keep them coming.
I don't see. Yeah, exactly. I don't see any more coming in quite yet. So we'll just give it a couple seconds.
You can also, if you have questions after the fact or you don't want to ask it here, you can definitely email me and I'd be more than happy to get back to you with whatever questions that you might have.
Perfect. Thank you. So questions coming in asking, is it a growing field? So Jenny, I'll let you take that one.
Yes, definitely. The opportunities, I think, in ocean tech in Halifax and Nova Scotia is, there already are so many opportunities and it is definitely growing. Yeah, I know at least for the NSCC Ocean Tech program, I mentioned that there's that sort of mandatory internship, and every year of that program, everybody gets an internship, no problem, because people are they want ocean technologists to come who have that background to come and work for them. So their opportunities are really endless. Yeah.
Perfect. And here's another awesome question. Was all the schooling you went through worth it in the end? What's one of the biggest takeaways you've had from it all?
Yeah, it definitely is. When I graduated my bachelor's degree, at that time in my life, I was certain that I wasn't going to go back to school and do my master's. It was not the path that I wanted to do at that point. I had just done a bunch of school. I wasn't really keen on doing more. And so that's sort of why I thought that the ocean tech program was so great. It was just 1 year and it really let me kind of take that university degree and apply it to something a lot more hands-on and a lot more technical, which is really what I wanted out of my marine biology degree in the first place. And then now that I'm in my position and I've had a few years out of school, going back to doing master's just kind of ended up being the right decision for me. And there will be a lot of other opportunities that come from doing my master's. So right now it was the right decision. And so no, I don't regret any of my schooling. It was definitely all worth it.
Perfect. How big would you say the industry is in Nova Scotia compared to other provinces? So if you want to just touch base maybe on aquaculture, Jenny, because I know.
Yeah, I mean, aquaculture here in Nova Scotia is, it's kind of growing. It's slow growth for sure. I'd say right now more in Newfoundland is where it's kind of the aquaculture industry is growing. But I think ocean tech is really kind of, it's limited to these coastal provinces. So here it's a pretty good hub. Newfoundland would be a good hub, and like BC would be a good hub, but probably not a whole ton of ocean tech going on in Ontario. We don't really have a lot of ocean to work with, but not to say it doesn't exist there. But I think definitely being in a coastal province is pretty key to that.
Yeah, and I think one thing that a lot of students and the general public don't realize is how much innovative technology that's coming out of Nova Scotia that's being used internationally and with other companies. So I think it's something that's really unique and special to Nova Scotia and to Canada as well. Yeah. But I know that you have sites, your company has sites all over the world, don't they, with sensors that are being used?
Yeah, we, I mean, we're primarily focused on salmon, but I mean, we do have sensors on other kinds of farms. And so the main kind of industry for salmon is here in Canada, in Scotland, Norway, and Chile. So those are kind of our main focuses, but I mean, we have some systems down in Tasmania, kind of all over the place.
So that means that some of your people at Innovasea is getting some travel opportunities?
Yes. Yeah, I was lucky enough I've been to BC to install some systems, and I've been to Norway to install some systems. And I was really hoping to get down to New Zealand to install some systems, but then COVID kind of hit and here we are. So stuck at home for now, but hoping to do a little bit more traveling in the future.
Yeah, and I find that that's not unique to aquaculture per se, but in the ocean tech industry in general, there is a lot of travel opportunities for those who are working just because of the nature of where we're working in the oceans and everything.
Yeah, you basically get to work in any kind of coastal place, and there are a lot of places that have long coastlines and are interested in ocean tech, and not to mention conferences and things like that take place all over the world. So lots of networking opportunities and more travel. So yeah.
Yes, exactly. This has been a great conversation. Again, thank you so much. I'll hand it back to you, Tristan, for a little bit if you want to just say thanks. I don't know if there's any more questions coming in. I've seen. So we'll do, and like Jenny said, there's an email there. It sounds like she's definitely open to you to send her emails for questions, and you can also forward them off to either myself or Tristan at Ignite, and we can also hand them off to Jenny as well.
Yeah, awesome. Thank you guys so much for joining us this afternoon. We really wanted to thank you for participating in this. It's like the first official kickoff of the whole program. It's really exciting. So the design thinking workshop is going to be on Saturday. And then the speaker series is every Wednesday at the end of the month. But Anna has more information on the design thinking. So
yes, so to continue the conversation that was started today, and thank you, Jenny, for really setting the context for us. We're going to be doing a really hands-on activity on Saturday, looking at building our own IMTA, which is an integrated aquaculture system, and we're going to be building that from recycled materials from your house. So make sure you read the email that I know Tristan and Kia Jade sent out that kind of outlines the type of materials that you have. But if you think about it, anything that you can build with will work for sure. The other thing that I'm going to ask you to do is if you have the ability to have a computer and a phone, that would be great, because we're going to be using a program called AHA Slides, which allows it to be really interactive. We can do quizzes and post questions like that, so it doesn't have to always just be through the chat function. And finally, I also want to say, if you're on this and you're a university student, you probably would have received an email from Tristan in the last couple of days talking about the opportunity for mentorship. So I'm going to stay on this call after we're done this, and I'll explain a little bit about how the mentor side of this programming works and see if you're interested in that as well. And of course, you're always welcome to join in for the speaker series. And thank you again so much, everyone, and Jenny and our funders and our partners for this.